I'm Stephanie Best, Director of Product Marketing here at Salt Security, and I am thrilled to be joined by Yaniv Balmas, VP of Research here at Salt Labs. I always love any chance to hear Yaniv's perspective, so I hope you find his commentary as insightful as I do. And he'll be talking a little bit more about his insights into the OWASP API Security Top 10 release process. So today we're going to start with a little bit about a recent report that we did around the OWASP or around API security and kind of how it relates back to the OWASP API Security Top 10. I'm going to pass the ball over to Yaniv, who's going to talk a little bit more about the process that this list came to be, what stayed the same, what's changed, and some key takeaways. And then we're going to have some time for some questions. So without further ado, wanted to again talk a little bit about the Q1 State of API Security report and kind of why that matters in this conversation. So a couple weeks ago, we issued our 5th issue of the semi-annual report, and it combines empirical SALT data with nearly 400 survey respondents and kind of what they found important in the world of API security and their current experiences. And I wanted to share a couple of key findings, again, related back to the OWASP Top 10, which sort of illustrates why this whole topic that we're discussing today is important. One of the questions that we ask is, what have you found in terms of security problems in production APIs over the past year? And 94% of our survey respondents had experienced a security problem in their production APIs. Importantly, 41% had experienced a vulnerability, but even more scary, 17% had experienced an actual breach. And that kind of brings us back to the world of the OWASP API Security Top 10. Who's actually focusing on this? We asked a question around, is your team focused on this critical top 10 list in their security program? And 54% of people said yes. Sadly, 33 said no, and another 12% weren't quite sure. But kind of brings us back to the why should everybody be focused on this. We took a look at our customer data over the last 12 months and took a look at the attack attempts that were being attempted against our customers. And 66% of them involved one of the top 10 methods or a combination of them. So as you can see, it doesn't quite mesh. Now, not as many people are concerned with this list, and they really should be, because so much of attack activity that we are witnessing is related to those top 10 attacks. And added to the fact that attack activity is increasing, we saw a dramatic increase in attackers targeting our customers' APIs during 2022, just skyrocketed. So towards the end of the year, that attackers have been really busy, and so they are attempting against these OWASP Security Top 10, and that's why it's really even more important that we're paying attention to that list and paying attention to the new list that's coming out, because it's going to be very insightful as we move forward. Another aspect, we asked our own customer data. We took a look and dug deeper into it, and like what types of attempts are being attempted. So you'll see that, there's a lot of injection and there's a lot of lack of resource and limiting. This is, again, the 2019 list. There's a significant amount of broken object level authorization, or BOLA, and broken user authentication. You'll see a little bit more when Yaniv starts his part of the presentation about kind of why these are uber critical. But, we're seeing just a lot of activity and, breakdown of what this looks like. And we actually provided this info to the OWASP group to help them better order their list. So I just wanted to share some of these findings with you so you can internalize a little bit about what the data is actually showing. And with that, I'm going to pass the ball over to Yaniv to talk a little bit about what stayed the same, what's changed, and his perspectives on that. Yaniv?
Okay, thank you, Stephanie, and then hello, everyone. Good morning, good afternoon. I wanted to, come here today and talk to you a bit about the new OWASP release candidate, As you might know, we've been deeply involved into the process of creating that. We cooperated with the OWASP API project management. We shared all our data and insights and helped influence this table. So I guess we do have a lot of insights that we can share with everyone. I've been seeing a lot of questions all around about why is this category more important than that one, or why did you choose this, or a lot of questions of this sort. And I hope that today, in the short time I have with you, I'll be able to cover as much as I can, and that you'll understand much more about this new list. One thing I want to say, and that's really important to remember, that what was released is the release candidate. That means that nothing is final yet. And that also means that this is your chance, if you'd like to contribute anything or change anything in the list. Everything is still open, OWASP, and we are looking for your feedback. So feel free to go into the link of the issues and enter whatever you want. If you won't do it now, you won't have a lot of chance later. So go ahead and do that. That being said, let's start. So what stayed the same in the new OWASP release? So the first thing, API 1, which is the most severe, most popular vulnerability, it correlates perfectly with what we see in our telemetry and with the vulnerabilities that we see in the wild. And this vulnerability is called BOLA, which stands for Broken Object Level Authorization. It's been there, as I mentioned in the previous OWASP API top 10, and the ranking stayed the same, so it's number 1. A few words about what is BOLA for those of you who are unfamiliar with that. The previous name or the other name for BOLA is IDOR. Maybe you're familiar with that, but both of them are talking about authorization issues, or basically permission issues. And that means that a lot of times using APIs, you can access different resources. Those resources are usually identified by some unique ID. So please give me document number 123, and you will get document number 123. The tricky part is that each document needs to have its own permission. Sometimes it's public, sometimes it's private, sometimes it could be protected. And when you're implementing APIs, it's very easy to make mistakes there. And it's very easy to not add permissions, or to add the wrong permissions, or anything of that sort. And when this thing happens, then you have Ebola. And that means that an attacker will be able to access resources that basically he doesn't have rights to access. And that might not seem very critical, because it's just a document, but it's not just a document. It could be every resource. It's, as I said, the most popular vulnerability. We see it almost everywhere. It's sometimes amazing to me how easy it might be to actually exploit Ebola. And on the other hand, the impact can be simply mind-blowing. Here's just one very recent example of a wonderful research made, by the way, by Sam Carey and friends, a brilliant researcher, an API researcher. And in this research project, what they did is take a lot of car manufacturers, and everyone uses APIs today, including our cars. And they just tried to find vulnerabilities there. And here's just one example of Ebola. There's many more in this research, but that's how they were able to take over Ferraris. Yeah, just a small, simple car, a non-expensive one, that is exposed to Ebola. And every Ferrari owner should be very worried because of this vulnerability. And trust me, there's a lot more where that came from. So I would say Ebola API 1, well-deserved, stayed at its same ranking as the previous version from 2019. Moving on. API 2, again, stay the same, and the title is Broken Authentication. Broken authentication is exactly what it sounds. Well, authentication is the way that you authenticate to a service, meaning that you need to identify yourself, right? This is one of the most crucial parts in any system design. If you have any flaws in your authentication process, you're in for very, very, very deep trouble. And this category talks about the generic authentication issues. So it doesn't talk about anything specific here. It might be a very wide range of authentication issues. And again, when you have a flaw in your authentication, that probably and usually means that someone can pretty simply take over your account. Sorry, some technical issues here. One very good example, in my biased opinion, is a very recent research that we released in Salt Labs, and it shows exactly this. It shows how we could take over practically millions of Booking.com accounts, the popular traveling service, Booking.com, and we did that by abusing flaws in OAuth. OAuth is social login functionality. So when you try to access service, usually you have this login with Twitter, login with Facebook, login with Google. Most commonly, underneath the hood, this is using OAuth, and that's exactly what we manipulated here, and that's how we managed to do account takeovers there, and that falls perfectly into the category of broken authentication. Obviously, it's not only OAuth, it's every authentication type. And again, it's very, very popular. We see it all the time in our telemetry. We see it all the time in vulnerabilities that we are able to identify in the wild. So again, well-deserved API 2 broken authentication. Moving on, API 4 also stayed the same. This time we're talking about unrestricted resource consumption. And that basically means that every service is using resources in various methods, in various ways. And resources is a very large word. Let's try to break it down. Which resources do we have in a service? So first of all, we have our bandwidth. If somebody is abusing your bandwidth, or AKA doing a denial of service or distributed denial of service attack, that will be a resource consumption. And maybe the first one that will jump to your mind when you say resource consumption, but it's definitely not the only one. There are many other resources involved here. For example, IO, input-output, is a resource as well. So just for example, if you have a file upload functionality in your service and someone decides to upload a 20 terabyte file to your service and you were not smart enough to block that, then you will most probably consume all of your IO resources. And same goes for memory resources or CPU resources or any other resource that your service uses. Anyone who does anything around there to trying to consume them will fall into this category perfectly. API 4, unrestricted resource consumption. And here is a very recent example. This time it's a DDoS attack. And the attack was an attack on Poland's key tax portal, which has a service online, obviously uses APIs, and some unidentified or yet unidentified attackers abused that. And Poland had a lot of trouble those days just because of this attack that falls under this category. So this was API 4. Moving on, API 5, broken function level authorization, or how I like to call it, BAFLA. What does that basically mean? So for those of you who are familiar, for example, with REST APIs, it's not only applicable to REST APIs, of course, but it's a very good way to explain that. If you're familiar with REST APIs, then any endpoint in a REST API can be queried using several HTTP methods. So for example, you can use a GET method if you want to get information. You can use the POST method if you want to insert your new information, or you can use update if you want to update, or delete if you want to delete, and so on and so forth. The problem here is that sometimes an endpoint can be used as a get endpoint just to get information, but in the back end, somebody just forgot another option there, post. It's not in the documentation. It shouldn't be available, but it is there. And attackers know to look for that. When they see a get endpoint, they will always try, for example, to use a delete option on that, whether or not it's documented, whether or not it should be there. And when they succeed, what they do is basically delete your resource. And this is something that you as the system designer or the CISO or whatever of this service completely didn't intend to happen. And it could, you can have a very bad headache when these things happen. And again, it's a pretty popular thing. We see it a lot in our telemetry. And here you see a vulnerability. We didn't find it. Someone else found it, but still it's a perfect BFLA. And it was done on Reddit. So somebody, so this hidden patch method, right, allowed anyone to approve Reddit posts without any consent. So basically, you can just post whatever you want. You bypass all the filters. You bypass all the permissions. For Reddit, this is very bad news, and it's all because of API 5, BAFLA, BFLA. Moving on, API 7. API 7 is, well, it is an API issue, but it's not only an API issue. It's an issue with basically anything that is computer related. And it's talking about security misconfigurations, right? So when you're implementing APIs, usually you're implementing them over frameworks, over cloud provider features, and so on and so forth. Each one of these components needs to be configured. And if they are configured improperly, then depending on the misconfiguration, there's a wide range of attacks that could happen to your account. And here we see, for example, supply chain vulnerability that was done on IBM cloud databases, which basically allowed unauthorized database access to a Postgres SQL that was available online and was simply misconfigured. I don't feel that there's a lot that I can say more about this category. Misconfigurations can basically be anything, but they are an issue, and they are a serious issue. And in this day and age, when it's so simple to set up your service, it's like Lego, take this part, put them together. It's very, 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 very easy to put online a working service. It's very, very difficult to bring online a secured service or a properly configured service. It takes much more time, much more knowledge. And I think this gap creates all of these misconfiguration issues. And again, we see them a lot, stayed in same ranking API 7 from 2019. Moving on, API 9, improper inventory management. Well, basically, what this category is talking about is a very common problem. APIs became so popular, and you saw, Stephanie showed you before all the statistics. And if you look at our report, you will see how many new APIs there are on a daily basis in the internet. It's really, there's an exponential growth of APIs. It's just all over the place. In fact, they are so popular and so big that as a company from a certain range, it's very hard to even understand which APIs do you even have exposed. A lot of, you'll be surprised, or maybe not, but a lot of the customers and a lot of the people that we are talking to, one of the first questions that they ask us is, first of all, before we do anything, we just want to understand where are all of our endpoints? Where are they? What are they? What do they do? It's a very, very, very big problem. It's a very serious issue. And yes, when you don't know what you have, you might be in for surprises. And again, not pleasant surprises. And as we can see in the Optus breach that happened actually pretty recently, where they exposed more than 11 million customer records with dozens of PII due to simply a forgotten API that was just sitting there exposed to the public. And again, you can see the numbers here. It's hard to say what, but $140 million that this company had to pay to cover the cost of this breach just because of a single API endpoint that was forgotten. So again, this category stayed the same as was in 2019, API 9, improper inventory management. That's what stayed the same from the 2019 report. And now let's go over what changed, the new categories that we have in this 2023 OWASP API Security Top 10, at least in the release candidate, so the things that we have so far. The first thing that changed is API 3. For API 3, we have a completely new category, and it's called Broken Object Property Level Authorization. Don't ask me to try and say the initials here. I don't think I can. But basically, what this thing is talking about, let me try and break it down in simple terms. If BOLA was talking about object access, so we have resources, we have objects, and we have permissions on objects, a document, right? And you have the permission to access the document. Well, this category talks about the properties of those objects. So maybe document is not the perfect example here, but usually when we have resources, they have properties assigned to them. And what this category is saying, it's not enough to only provide the permissions on the object itself. You should also go into a more granular level of defining the permissions on the properties of this object. Other than that, it stays pretty much the same as BOLA, but I think it's a very good differentiation between BOLA and this because it kind of falls into different categories. And from an attacker's perspective, it's a bit different to abuse that and to abuse that. And also from a defensive perspective, it could be very different to define permissions on objects and on properties. And this is the main reason why they are split into two separate categories. But as long as you understand the idea, you should be okay here. And again, this is a good example of that. A very good example, a Twitter breach, an incident that impacted a lot of accounts and a lot of private information on Twitter just because of object property permissions. So keep that in mind. And this is our new category, API 3, Broken Object Property Level Authorization. Moving on, API 6 got a new category, a new name, and this is if you've been around web security anywhere, anytime, basically, you should be very familiar of this term, service-side request forgery, or in its shorter term, SSRF. Let me try and explain for those of you who don't know what SSRF is, what it is. Again, I try to do it as simply as non-technical as I can. So basically, an SSRF condition or vulnerability happens when in the backend you have some kind of endpoint or some way to receive URLs from untrusted sources, basically from users or from any data that is untrusted by you. It's not yours. So when a user needs to send you a URL, sometimes this is perfectly legit. Somebody needs to send the URL to your endpoint. That's good. The question is, what does your service do with this URL? If, for example, he's trying to connect back to this URL, then I will ask what will happen if the user will provide some other URL. Just for example, a URL of a server in his control, right? If you will then take this URL and blindly just try to connect to it, you might also send a lot of sensitive information along with that. And we have a very, very good example of a research that we did very recently It was on a company owned by Lego, used by millions of users online, and they did exactly this mistake. They received URLs, they didn't sanitize them, or they just blindly accepted whatever anyone inserted there. And we inserted, as I said, a URL of a server that we own, and then they send us a request. And what do you know? This request contained a token, and this token was the administrative token for the entire service. So we can just now take this token, use it in other requests, and basically we'll be identified as the service admin, and we'll have service admin rights, and we will be able to do anything that we want on this service. So it might sound not so severe at first glance, I would say, but when you think about it a bit deeply, you understand that there's a lot of trouble waiting for you if you don't sanitize user input in general, and specifically URLs. Obviously, it doesn't. There are many flavors of SSRF. It's not only connection to external resources. It can also happen when you're connecting to internal resources. There's blind SRFs and non-blind SRFs. We won't go into that. I'll just say that the attack surface here is quite wide. And again, I think it's been long awaited by a lot of us from the community to see SSRF getting its place inside OWASP API Top 10, and hopefully the 2023 final edition will still include this SSRF. We are pretty confident it will, but that way or the other, it's a very serious vulnerability that you should all take into account. Moving on. API 8, lack of protection from automated threats. What this category is trying to talk about, maybe it will be the best to explain this with an example. And this is, by the way, I'm using the very same example that's being used in the release candidate itself, although I have a lot more if you need them. So in this example, there is some company that's planning, they just developed a new product, a new, I don't know, console, gaming console, and they have a very limited stock of that new gaming console. And yes, they want to, do it or try to sell everything in Halloween, for example. Now, there is some attacker sitting in the internet, and he sees that. What he does is just goes in and buys all of the consoles. All of the consoles. There's a limited stock, as I said, so yeah, it might cost him a bit, but he can definitely buy 100, 200, 300 consoles. Then he just goes and sells them for a higher price, and the company doesn't have anything to do with that. Now, the thing with these kind of cases, right, first of all, usually they are automated. Not always, but usually they are automated. And when you come to think about it, there was nothing malicious done here. So the so-called attacker, he did nothing malicious. He just bought consoles, and he's allowed to buy consoles. And if you look at each request individually, yeah, this is a purchase request, a purchase request, a purchase request, perfectly valid request. Everything is in order, not a problem. Only when you go up and look at that from 50,000 miles view, then you understand what's going on, and then you understand that there is some kind of abuse going on. And this was just one example. Again, you can see another example that we put here where researchers abused URL shortener services and its business logic by performing an automated attack. They took over accounts of companies using this service. It was a big research and it was a big story. And these things happen all the time. Again, the technical barrier to conduct these kind of attacks is, I would say, very low. You don't need to know anything other than how to automate API calls. The consequences could be dear. Also, from a defensive standpoint, it's not trivial to block these kind of attacks because, as I said, they almost look legitimate. They look legitimate to, you need to put a lot of things together. You need to have a lot of context, a lot of memory to put everything together and then to understand that this is an attack. It's not an easy task to do engineering-wise, but it is doable. So this is API 8, lack of protection from automated threats. Moving on to the final category, and this is API 10. API 10 is a bit of a special category, and it's talking about unsafe consumption of APIs. Now, this is a very big word or big term, unsafe consumption of APIs, and it needs some explanation. And I also think that the final version will change a lot of the terminology, because there were a lot of comments about the terminology in this release candidate, but I do think that the concept will stay the same. So what this category is talking about, and if you've ever been involved with any vulnerability research or read about any vulnerabilities, you probably know that user input is the source of all evil. You saw that in SSRF. You heard about it probably in many other places. Wherever you're receiving input that is untrusted from an untrusted party, you can't blindly trust them, because a lot of things can go wrong. The interesting thing is that this concept has been with us for ages, since whenever the first vulnerability was found in the world, we knew that. And yeah, I think developers and security practitioners, they already know how to address that, and they already understand that. So just for example, SQL injections, right, were very popular like 10 years ago. Today they are far less popular. And the reason for that is because people know how to sanitize user input. And that's all nice. But for some reason, when we're talking about APIs, let's say that usually APIs are delivered over JSONs, right? Over JSON data structures. For some reason, when people receive data in JSON, they trust it. They say, oh, it's JSON, it must be okay. And it doesn't matter if this JSON was, just built by the same malicious actor that just, did and tried to do an SQL injection a second before. It's something very psychological. I didn't analyze that, but it is true. And people don't sanitize enough input when we're talking about APIs. And that's the very sole reason why it deserved its own category, API 10. And as you can understand, this category will include underneath it a lot of different vulnerabilities. It's not talking about a specific vulnerability like Ebola. It's talking about the concept. So it will include every injection vulnerability known to man, and those that are not known to man as well. It will include deserialization and desync attacks, and many others. And maybe the perfect example I can give you from previous year is the Log4Shell vulnerability. Log4Shell was an amazing vulnerability. Amazing. I'm just saying, I come from a vulnerability research background, so for me vulnerabilities are amazing. I'm sure that not for everyone, but it really depends on your perspective. It was an amazing vulnerability just because it sat there for so many years. It was so easy to exploit, and it was simply everywhere. All you had to do is log into Twitter, change your username to be JNDI, home, something, and that's it. You can take over Twitter. It was simply that. It was crazy. It was crazily dangerous. And I think now it's already much better because a lot of people have upgraded, but it is still a perfect example of API 10 of unsafe consumption of APIs. And that concludes my my review of the new OWASP API Top 10 release candidate. And again, I urge you to, if you have any comments, if you think that anything that I said should be prioritized differently, or if you have another category in mind that you want to put into OWASP API 10, this is the time. Go submit your issues, and I promise everything will be reviewed and considered. Thank you very much. Stephanie, off to you. And if anyone has any questions, I'll be very happy to answer them.
Fantastic. Thank you, Yaniv. That was amazing, as always. One quick comment, in the process of this conversation, we had a couple of questions for the requesting the slide deck. So you will now see that in the related resources tab. So thank you all for your suggestion there. You'll also find a couple things, the State of API Security report that we referenced earlier, as well as a blog that Yaniv did recently on this exact topic. So if you want to kind of read some of this in written form, you can take a look at that. So at this point, if you have any questions, we'd encourage you to put them into the Q&A. We do have several that have popped through already. So Yaniv, I'm gonna just hit you with some of them. The first one is from Carla, and she's asking if you can explain the difference between BOLA and broken authorization.
BOLA and broken. Well, I think I covered that in my presentation, but basically, BOLA is talking about the permissions issue. So again, going to the example of documents, right? If there's a document that you shouldn't have access to, and you can still access it using APIs, then you're exploiting a BOLA. Broken authentication talks about something else. It's talking about the authentication process to the service. So basically, if you're able to manipulate in any way the authentication process and kind of log in as a different user, then you have a broken authentication issue. And again, usually this will lead into account takeovers, which could be very severe.
Fantastic. William actually has a similar question. Can you please elaborate on the main difference between API 1 and API 5?
API 1 and API 5, the new one. So let's just let's just roll back here and see what was API 5. It was BFLA, right? Yeah. So again, so API 1, there's no need to explain. I already explained it. BFLA, or broken function level authorization, is something completely different. It's usually, the condition is usually when you have some kind of hidden endpoint, or not exactly a hidden endpoint, but a hidden option to an endpoint. So if an endpoint is supposed to just, return information, but you can also delete information just because it's exposed, shouldn't be exposed, but it is, then you have a BFLA condition, and it works in, whether you delete, whether you update, or whether you post information into that, it's all pretty much the same, and that will be BFLA. So a very different thing from BOLA, from API 1.
And don't get too far off this track, because he has a follow-up question. Similar question, can you elaborate on the difference between API 2 and 3? I'm gonna make you move around the slide deck a bit.
Okay, so 2 is an old category, and this is broken authentication, yes. and I already explained a bit about that. Again, when you have an authentication, and you can, as an attacker, some kind of exploit or manipulate the authentication process, then you have a broken authentication issue. And API 3, I'm assuming you mean the new API 3, right? Yes. Is a broken object property level authorization, which is talking about a permission issue with a property of an object, not the document itself, but something written inside the document. So you shouldn't have access to this specific credit card that's listed in the document. You can access the document, but you can't access this credit card. And if this goes wrong, and if the permission there is wrong, then you have a BOPLA condition.
Perfect. Okay, Gaurav is asking if there's a logical first step that you would suggest anyone take to start getting ahead of these top 10 attacks.
First of all, know them. Know them, understand them. But when I say understand them, I mean really deeply, technically understand them. I gave you here the very, very short brief. There are people that are spending months and years to understand every bit and byte of this. You can do this yourself, or you can just ask someone who already did this before. And there are many, many, many things that you can do. So OWASP API Top 10 doesn't talk about how to protect. Yeah, of course, there are recommendations on how to protect everything, but there are really very generic recommendations, because frankly, no one can give a very specific recommendation. It will be very dependent on your implementation and your API design. What you really need to do is, after you really understand those top 10 attacks, see how they relate to your environment. Sometimes not all of them can be applicable to your environment. I think usually most will, but yeah, not always. And once you understand which ones are relevant, try figuring out ways how you can prevent them. I can't really go through all the options because they are endless. And if you can't figure this out yourself, I urge you to find someone who understands enough and can guide you to that. And obviously, even if you can't protect it, I mean, if you can't protect it in your development stage or in your testing stage, you should also try to protect them real time on your network in real time. So those are the available options. And yeah, that's basically what you can do.
Thank you. And as always, you can call us if you need help. Steve is asking if SALT is making any changes to the product as a result of these OWASP top 10 changes.
No, good question. First of all, we are always doing changes in our product, regardless of OWASP or not OWASP. But yeah, we very much appreciate OWASP. And as I mentioned before, we work very closely with them. And if there's a change in OWASP, it's something that we need to be aware of, first of all. And yes, we do need to make sure that our product supports all the new OWASP API top 10 attacks, which I can say that it is. And it has always supported them, even before they became attacks in the new OWASP categories. But now that they are, it calls for another review and to really make sure that everything is there. And yeah, we have already finalized all the steps. And if you want to be protected against these threats and others, our product is ready.
Beautiful. All right, a couple more. Alejandro is asking, was there anything about this release candidate that surprised you?
That surprised me? Wow, that's a good question. I don't really think so. But maybe I'm not the best person to ask this question because I deal with vulnerabilities day in, day out. That's what I do. I've been doing this for a lot of time, so it will be pretty hard to surprise me. Sometimes I am surprised. I must say that no, I wasn't surprised, and I think the reason I wasn't surprised is because the OWASP API Top 10 was built on top of a lot of data, and this data is of things that are happening in the wild, the most popular things that are happening in the wild, and those things are things that we see, again, day in, day out, so it will be very hard to surprise me regarding API attacks, and no, I don't think I was surprised from any of these new categories.
Perfect. All right, Venkat is asking, can you talk about API security testing processes and procedures and how they can or can't help cover the OWASP top 10? So security testing.
Security testing. Well, security testing is a great thing. It's a great thing in general and APIs as well. And yeah, it can help you cover grounds and it can help you protect your services. But you know, every solution has its upsides and its downsides. And if you're asking about the upsides of security testing, I just told you about them. If you are asking about downsides, the downsides are that you need to write a test for every specific case, and it's very hard thing to do. You can't really anticipate all the edge conditions. You can't really anticipate everything. So yeah, you can cover with security testing, I don't know, 20, 30, 40, 50, 60% of the vulnerabilities. There will still be a very large gap that you won't be able to anticipate. And again, this is just one problem. Other problems comes from, you have CI/CD today, for example. So somebody writes something, some code, 5 minutes later, it passes some testing and boom, it's in production. How do you do that in an efficient manner? So just for example, we talked about resource consumption. How do you test resource consumption? In 5 minutes. It's not an easy thing to do. It may be done. It's a big challenge. I do think that you should not, put any testing aside, it's a crucial part of any development stage, but I really don't think that any security testing should come instead of other protections, like real-time protections, for example. Yeah, that would be my insight on that.
Fantastic. And we have time for one more question, also from Venkat. He's got a couple of great questions here. Yaniv, what's your opinion on using MFA for API authentication? And he specifically references API keys, tokens, and especially as it relates to handling sensitive data.
MFA stands for multi-factor authentication. A couple of things that you can say about who are you, what do you know, what do you have, questions like that. And yes, look, MFA is not an API specific feature, right? You can use that on anything else, but yes, of course, you can use it on APIs, and I think it's a very wise idea to use it on APIs. I think mostly it relates to, if we're talking about in the context of OWASP API Top 10, it will relate to API 2, authentication issues. And again, if you put an MFA on your authentication method, it probably means that your authentication is stronger, bigger, and better, but take into account, again, it really correlates with the example I showed you of the recent OAuth vulnerabilities that we found in Booking.com. They had MFA there. They had a social login, which is supposedly a very strong and very secured login type, but it wasn't implemented correctly, and that allowed us basically to break the authentication. So bottom line, I would say that MFA is a very good thing, but be very careful in how you implement it. Make sure it's implemented securely. Make sure you have no loose ends in there. And if this is done correctly, yes, your APIs will be more secure. If it's done incorrectly, less.
Yaniv, thank you so much for this great conversation. I think it was incredible and eye-opening, and I learned a lot, and I hope our audience did as well. A quick reminder to everybody out there, please check out the resources on the related content tile. I hope you find a few things in there with some great takeaways. If you have an API project on your radar for 2023, make sure to reach out to us. We'd love to get a chance to show you the SALT platform in action and how it can address the OWASP API Top 10 2019, 2013, and everything else in between. We're going to make this webinar available on demand. You should get a link later today or tomorrow, so you can watch parts again or share with your contacts and colleagues. If we didn't get a chance to ask your question or answer your question, I know there's a few in there that we didn't quite get to. We'll make sure to get back to you directly. And if you didn't get a chance to ask your question, reach out to us. Let us know what's on your mind. We're always happy to answer questions. We have the industry's only dedicated API research team led by Yaniv here. So lots of great info that we can help share with you, and answer any questions and support you in your journey as you protect your APIs. So in closing, thank you so much for spending part of your day with us at SALT. We hope you have a fantastic rest of your day and look forward to seeing you on a future webinar. Thank you.